Okay, with the addition of the command, you will be able to compile the program now. So now it's working, so you can see the same output as before. It's just it's just a simple amendment before you do the assignment pointer and variable assignment. You declare is now pointer, right? So the example in program 9.2 is actually the same as what I've done here. You may want to try it on your own, right? But now if we access the pointer p pointer, what we get? How do you get the value of p by using p pointer, because it's pointing to p, right? So this is the access to p from p pointer is being enabled by this indirection operator or dereferencing operator, this asterisk. Okay, this asterisk is different than the declaration asterisk. This asterisk, it appears in your at cout, or when you are using you're using it to access in your code, inside your code, not at the declaration point. Okay, in accessing value. So if I just add this asterisk p let's call pointer. So what I'm doing here is I'm actually accessing the value that is being pointed by p pointer, right? So if I compile this, you will see that at the end you get 10, which is the value of p, because p pointer is pointing to p, and when we use the null pointer, when you use the asterisk, the indirect operator, alright, or dereferencing operator, it's assessing the variable that is pointing to. Okay, so the asterisk on the declaration part, the declaration means to show that this is a pointer. The asterisk inside the body means that it is assessing the variable that is pointing to get the value. Okay, right, so do not be confused. Okay, do not get confused here. So different asterisk meaning here. Okay, we can try out this code on your own and see whether you get the results. So how do you initialize the pointers? Okay, so pointer initialization, you have you can do something like this, just what we have done here. int p equal to 0, 10, this is variable, then the pointer initialization, now pointer, and ptr equal to the address. But you cannot mix data types, so if you want to point to a integer, make sure that the pointer is integer pointer. You cannot do something like this. You have a variable called cost. Where's my mouse? Where you have a variable called cost. Okay, you have a variable called cost here, and then you want to you declare a integer pointer, and you want to do this assignment. This won't work. Okay, you can also test for invalid addresses for pointer. So if not a pointer, then what happens? You can do this. Okay, so comparing pointers, you can use relational operators to compare pointers. So you can compare pointers for their addresses, whether they are pointing to the same address, or you can also compare contents. You can check whether they have the same contents. They might be pointing to different address, but whether they have the same content or not. Okay. So these are some operations on pointer variables. So you can do initialize, you can do assignment. This uh, this can the first four, the first three can only be done if you have two pointers and pointers. Like you declare NTP, pointer P, asterisk P and asterisk Q. So P equal to Q is a valid statement. Okay, if you declare int asterisk P and Q only, this would not be a valid argument statement. Okay, so this will only be valid because of this. Okay, they are equal, they are pointers. So pointer P, you're checking whether pointer P is equal to pointer Q. You are assigning the address of uh, pointer P to have the address of pointer Q. Okay, and this is checking whether the pointer P address is equal to pointer Q address. Okay, and P is not. This is checking whether pointer P is not equal to pointer Q address. Okay, and these are some pointer arithmetics. So you can do P plus plus, P equal to which is equal to P plus 1, Q plus plus, and if you are using character pointer plus plus, you can do this plus plus thing. Is more feasible when you use array, but you can also do this for individual single variable. But what happen is the size is actually moved to the next 4 bytes. Okay, so we'll see this in your exercise. Okay, let's move to reference variables. So just now it was an introduction to pointer variables. So what is reference variables? Reference variables is just another additional name to an existing memory location. It's like an alias. Okay, so in pointer you have integer x, you have integer pointer ref, and you have this assignment. Okay, you have this ref equal to the address of x. So what happened is ref is pointing to x. Okay, but in reference, okay, you have variable x equal variable x. Okay, and then you have this address of ref is actually x. So they are actually sharing the address space. Okay, in reference, so it's sharing the address space. In pointer is pointing but two different addresses. One, the pointer is pointing to the address of x, but in reference is ref and x is sharing the address space. Note on the differences of declaration here. Okay, x and asterisk ref, and this is the assignment. Ref equal to %x. For reference, you declare x first, and then you declare ref, not as ref, but address of ref equal to x. Okay, there is no such thing as ref only for reference. So you have to declare as address ref equal to x. Okay, so this is the notation. Alright, so let's try to do something like this. So this is pointer. So I'm going to declare another. Right, let's just let it be like this. So I'm going to declare int p ref. Sorry, p ref. Okay, so I cannot just declare p ref equal to p. This is wrong, because it's just if I declare this, what happen is it will create another variable p ref in a separate memory location and store the value of p inside it. But what I want is a reference, a reference of p ref to p. So which means that uh, I'm actually looking at p, assessing the value of p, but using another name. Okay, so uh, it's just that I'm still accessing at the same memory address. So this is um, pdef. So let's try to see out, and we just see out um, the address of pref. Okay, I'll just see out the address of pref down there. See out address pref and line, and I want to also see out the value of pref. P underscore ref. Sorry, it was underscore. And line. Right. Let's compile this. Right, so now we run. So you can see now, okay. So let's make it smaller. You can see now these 5 lines is this one. P, address of P pointer, okay, address of P pointer, and the value that is being accessed by P pointer, which is P. So now we are left with these two below. So the address of P ref would be the same of the address of P, which is 070FE44, and the value of P ref is 10 because they are exactly the same, it's just different name. Okay, the reference variable always refers to the same. The reference variable always refers to the same object. Assigning a reference variable with a new value actually changes the value of the referred object. And these reference variables are commonly used for parameter passing to a function. Okay, so let's say on the point number 1, okay, I want to change the value of pref into 20. Right? So when I change this, I want to see out pref and line, see out P and line. Okay. So let's this together. Okay. So compile. Sorry, keep doing the same mistake. Right, run. So what happened is the value is now changed to 20. Pref is 20, P is also 20. Okay, you see that P, the value of P pointer is also 20. Let's compile. Run. So you got 20. So if I want to change P PPTR here,